right, this is Geometry A, Unit 6, Lesson 2. This unit we're getting into formal proofs, and we're going to be using logic. And so in order to understand logic, it's important to understand if-then statements or conditional statements. So this lesson is on conditional statements and their variations. I have here a statement that is a conditional statement. If it is a Dalmatian, then it is a dog. It's a statement that makes some sense. If you have a Dalmatian is a type of dog. You can conclude that what you have is in fact a dog. All right? And this can be expressed in a number of ways. A Venn diagram is a great way to express it. Dalmatians are a subset of dogs. So of a bigger group, dogs. Okay? So Dalmatians are a subset of a bigger group called dogs, and this is a Venn diagram. So if you belong to the set of Dalmatians, you necessarily are also inside the circle for the dogs. So you are also a dog. Contrary, if you are not a dog, you are also not in the Dalmatian circle. And we'll get back to that here in a minute. But the parts of a conditional statement are as follows. Okay, we have the if part. The if part, it is a Dalmatian. This is called the hypothesis. And there's some confusion over this word being called the hypothesis because in science we consider a hypothesis to be a reasonable explanation for why a phenomenon occurs. That actually is not what it is in mathematics and logic. In logic, the hypothesis is the if-then, the antecedent, the condition that must be met for the conclusion to follow. So hypothesis is the if part of the statement. The then part of the statement is called the conclusion. It is a dog. Conclusion. We can shorten this statement to A implies B. A implies B, where A is, it is a Dalmatian. B, it is a dog. A implies B. Okay? All right, so there are some variations we can make on this statement. We can switch the order. If we switch the order, this is something known as the converse. The if part and the then part are switched, or they trade places. And I would say if it is a dog, and I'm going to shorten this here. If it is a dog, then it is a Dalmatian. Now you can see right away that this statement is very different from the original statement. Okay? But the if part and the then part have been switched. The hypothesis has become the conclusion, and the conclusion has become the hypothesis. Or that is to say, the argument has become B implies A. Okay? Now you can conclude, hopefully, rather quickly, that this statement is false, where the original statement was true. If you have a Dalmatian, you have a dog. This statement, the converse, can be readily identified as false because I can come up with something called a counterexample. My counterexample in this case is a foxhound. Because a foxhound is not a Dalmatian, but it is a dog. If you can come up with one example that satisfies the hypothesis but does not satisfy the conclusion, this statement is proven false. It's easy to prove a statement false. One counterexample is necessary. Okay. And by the way, if we are in the dog circle, we are not in the Dalmatian circle, we might be in the foxhound circle, right? So it is possible to be in the dog circle and not be in the Dalmatian circle. So the Venn diagram makes that true as well. All right. I want to introduce another word, negation. Negation. That is to say something that it is not. right? So we would say not a dog or not a Dalmatian. Not a dog. Okay, that would mean it's anything but a dog. It is part of the set that is not dog. A rock is not a dog, so a rock would be part of the not dog set. Okay, now if I want to negate the original statements, going back to the if it is a Dalmatian, then it is a dog. If I negate both, if it is not a Dalmatian, then it is not a dog. This is a statement that is known as, or called, the inverse. Inverse. Okay, if it is not a Dalmatian, then it is not a dog, is the inverse. And we designate this statement as not tilde. A implies not B. And again, this statement has a truth value that is false, because I can come up with a counterexample. If it is not a Dalmatian, well, a foxhound is not a Dalmatian, but a foxhound is a dog, so it would make the conclusion false, even though the hypothesis is true. Okay, all right. So then, if we do both negate and switch, we have the following statement. We have, if it is not a dog, then it is not a Dalmatian. Okay, think about that for a little bit. If it's not a dog, like if it's a cat or a rock or a fish, okay, we call this the contrapositive. 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 And the symbol for this is not B implies not A. And this happens to be true, because if you're looking at the Venn diagram of dogs and Dalmatians, if you're outside the dog circle, you are necessarily outside the Dalmatian circle. And so this is true. So the contrapositive of the original statement has the same truth value as the original statement. We say they are logically equivalent. Okay? And I will conclude this video by saying this. Not every conditional statement needs to be written as an if-then statement. If it is a Dalmatian, then it is a dog is equivalent to saying Dalmatians are dogs. Dalmatians are dogs. That's another way to say, if it is a Dalmatian, then it is a dog. But you need to be able to recognize it as such, and you need to be able to write it as an if-then statement. Okay? If I say the statement, rocks are heavy, right? Then I can write that as a conditional statement. If it is a rock, then it is heavy, right? So they are equivalent in English, but we don't necessarily have to use the words if and then.